Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal Hafiz bin Karel Anwar, matrix number AD190056, and I will talk about the introduction for our group assignment. Okay, first, what is solid mechanics? Solid mechanics is one of the important branches of physical science concerned with the deformation and motion of continuous solid media under applied external loadings such as forces, displacements, and accelerations that result in initial force in the bodies, thermal changes, chemical interactions, electromagnetic force, and so on. So for our course, we have learned 6 main topics that are crucial in mechanical engineering study, which are strain analysis, deflection of beam, buckling of columns, strain energy, thick cylinders, and theories of failure. These chapters are very important for mechanical engineering students as we always work with this aspect in order to find the best solution required for each type of problem. So for our group assignment, we have at least 5 real-world problems, and one problem have been chosen in order to implement what we have learned throughout this semester. Our group have decided to choose problem number 2, which is beam deflection. When designing a beam, when calculations are made in order to choose a beam which is strong enough to carry its load, at least 4 items must be considered, which are the beam must have a bending strength adequate to resist the bending moments. There must be no danger of failure due to shear forces. The amount of the beam bend, example the deflection of the beam, must not be excessive. There must be no danger of lateral buckling. The amount of beam deflect depends on the way it is supported, the amount and position of the load, the span of the beam, the size and shape of its cross-section, and the nature of the material. All other factors being equal, a beam with its end fixed deflect less than a beam with its end simply or freely supported. The effect of span of deflection is very important. That's all, thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Muhammad Zarfan bin Ahmad Azri with matric number AD190086, and in this video I'm going to present about our method of assessment. So for the purpose of this group project, the method used in determining the data and information are by using the quantitative method, or much precisely online quantitative research method. The data and information are solely collected by using the medium of internet through the online articles, website, and Wikipedia. So there are 5 real-world problems involved in this course that we need to find, and we have already assembled it. So between the 5 real-world problems that have been gathered, the real-world problem about deflection are chosen as our main focus for this group project. We all concerned to utilize the beam deflection as our main focus of the real-world problem, and afterward proceed to separate the responsibility of this report. So we move on to the next one, which is we need to calculate the beam deflection because we have chosen beam deflection as our main focus. So there are things that we need to consider. The first one is modulus of elasticity, moment of inertia, amount of the distributed load. And next, we also need to conceptualize, then proceed with the first step, which is conceptualize. In this step, it involves the understanding of interpreting the figure of the problem into free body diagram. The second step is to categorize, and in this fourth order differentiation is involved. Moving on to the third step, which is analyze. In this step, understanding of shear force, bending moment, angle of rotation, and others must be high in order to solve the problem completely. So for the third one, we have to do simulation. So the outcome obtained from calculation part is approved by using simulation, and the simulation we use is programming method C language. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Razmi, matric number AD190080. So next, we go for the calculation part. So in this calculation part, we are going to determine 2 things, which is the first one would be the deflection of the cantilever beam, and also the angle of rotation. So if you see in this figure below, this is the beam, and this red line is the deflection curve, where in this case of the cantilever beam, this there will be maximum deflection occur here at the free end of the beam. So we are going to find these two unknown, which is the deflection of the beam and also the angle of rotation of the beam. So we are going to look at the calculation. So here, as for the calculation, this is the free body diagram of the cantilever beam. We can see this Q naught here denoted as the distributed load, and this L will be the full length of the cantilever beam. And from here we can have this equation of the intensity of the distributed load, which is Qx is equal to the Q naught L minus X over L. And then from here we can make this fourth order differential equation. EI will be negative Qx equal to this equation. So we'll set this as the first equation. Then do the first integration. Then we get this Q naught over 2L L minus X squared plus C1. So we need to find what is the C1. So to find C1, we are using the boundary condition, which is the shear force is 0 at the X equal to L. So we are substituting this boundary condition back into this equation 1, and then we get the C1 equal to 0. Then substitute back C1 equal to 0 into this equation, and we get this equation, and set this equation for equation 3. So substituting back the C1 equal to 0 into the equation, we get the shear force of the beam will be in terms of this equation. So next, for the bending moment in the beam, we are also doing the same thing, which is integrating this remaining equation. Then we get this equation, this negative Q naught over 6L L minus X cube plus C2. So the same, we are to find this C2. So we are using the boundary condition, which is the bending moment is 0 also 0 at the free end of the beam. So we are using this, substituting this into this equation 4, 0. Then we get the C2 is equal to 0. Substituting C2 equal to 0 into this equation, we get bending moment. The bending moment is equal to Q naught over 6L L minus X cube. And then we have to find the slope and deflection of the beam. So by taking this remaining equation, we are doing the same thing with integration, 2 times integration. Here's the first integration. We get to this equation, and one more integration for this equation, we'll get this equation. So we have to find these two unknowns, C3 and C4. So again, we are using the boundary condition at the fixed support. Now we are using the integration at the fixed support, where both slope and deflection are equal to 0. There are no, as we can see here, there are no deflection occur at this fixed point of the beam. So by substituting these two boundary condition, we are going to get this C3. So we get C3 here, then substitute this C3 into this equation 6 to get this C4. Then after substituting the C3, we get the C4. Then substitute back this C3 and C4 into this equation 6, and we get these two equations. The first one will be the equation of slope from equation 5, and then the next one will be the equation of deflection from equation 6. Okay, so by getting this, we are getting closer to the answer for this problem. So there are one more unknown we have to eliminate here, which is the x. So that we can get the deflection, the answer we want, the two answer we want, the deflection of the beam and the angle of the deflection, angle of rotation, in terms of E, the Young modulus, the I, which is the moment of inertia, the L, the full length of the beam, and also in terms of Q naught, so distributed load. So we are eliminating the unknown of x, which by substituting x equal to L into the equation, to these two equations, which gives us this answer. The angle of rotation is Q naught L cubed over 24 EI. Also the deflection of the beam equal to the Q naught L power 4 over 30 EI. So after we get this, then we are going to substitute the value of the unknowns so that we get the value of the angle and the deflection. So we are using the distributed load of 500 kilonewton per meter, 30 meter for the length of the beam, 200 gigapascal for the modulus of the young modulus of the beam, and also 0.005208 meter for the moment of inertia. Now substitute all this value into these two equations. We will get the angle of rotation will be 43.94 millimeter, and also the deflection of the beam will be 400. So this means that the maximum deflection occur when 500 kilonewton loads being held on the beam, which gives us this amount of deflection for the beam. So I think by solving the first order differential equation of the deflection curve, we can get these two answers for the calculation. So I think that's all for the calculation part. Thank you.
Okay, I am Ahmad Adi bin Najib, one of the group members from Group 8 Solid Mechanic 2. So I'll be talking about how do we verify our result. How do we verify our result obtained from the calculation shown just now? A famous philosopher a long time ago named William James once said that truth for us is simply a collective name for a verification process, which implies that it is important for us to verify something that we said. So there are 4 steps that we did to verify the result. The first one is to make sure the formula we obtain from the fourth order differential equation is correct, which by comparing the result from the lecture note, from the learning material that we collect from author and some other information from Google itself, it is indeed that the formula we obtain is correct. And the second one is determine the fixed value that will be used in the programming that we will construct, in which in our case it is Young's modulus and the inertia. So for the third one is this is one of the most important part, which is to construct a simple program using the online compiler and debugger, which can be found on Google. So we construct a simple program using this online compiler, and from the online compiler we managed to make a program that will give us a result about the thing that we want, which is in our case it is an angle of rotation and the deflection of the beam. And the last thing is we need to check whether the value obtained from both the calculation and the program that we construct just now is the same. And in our case, both the value is the same, which further tell us that the verification that we did is correct. So this is one of the example that we did. On the top left and right, you can see the compiler. We can see the programming that we wrote on the compiler, and in the bottom we can see the result. In which the result from the program is that the program will ask us to input 2 things, which is the distributed load over the beam and the length of the beam, and it will give us 2 calculations. It will give us 2 results, which is the angle of rotation and the deflection of the beam. So for discussion, we use fourth order differential equation to obtain the equation that we want. So by completing the fourth order differential equation of the deflection beam, of the deflection curve, by completing the first differential equation, we managed to obtain the equation of the intensified load of the beam. And for the second one, we managed to obtain the bending moment. The third one, we managed to obtain the equation of the slope, and for the last one, for the fourth order differential equation, we managed to obtain the equation of deflection. We use the third and the fourth result, which is the equation of the slope and the equation of deflection, in which both of these will be used for us to find the result for angle of rotation and the deflection of the beam. I think that's all from me. I'm Adi bin Najib. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syafitri bin Shahrin, number matric AD190184, and I'll be continuing with the report's conclusion. Now, the conclusion for the report is that to study the beam deflection. It is the aim of the report. A beam is a key unit in most buildings. The analysis of beam deflection under a given load, which is critical in this case. Beam deflection in the state of the beam deforming from its original shape due to the works of force, load, and weight. Obtaining the equation that can be used to calculate the beam deflection is one of the most important applications of beam deflection. The deflection of cantilever beam free end is calculated using the results. While the deflection of the cantilever beam is the greatest, it is proportional to the mass applied to the beam. The smaller the gradient of the line of each graph, the higher the modulus material. The equation predicted a linear relationship of the beam behavior. The actual deflection is always less than the theoretical deflection. This is very crucial, that we found out from the report. The deflection of the aluminum beam is simply with supported beam is significantly less than of the cantilever beam. The beam deflection is proportional to the mass applied to the beam. That is all. Thank you.